Instruction set means there is a list, or you can say a catalog given by the manufacturer of 8086. If we are going to use 8086, there are few instructions we need to follow. Fine. So it's all about that list of instructions. If you want to use 8086, we need to take care of those. We need to use those instructions because 8086 will understand only those instructions. All right. So what I want to focus is, you just remember one thing always. Every microprocessor, either it is 8085, 8086, or the family of 8086, then a different family, Pentium, they all will be having a different instruction set. Every microprocessor has a different instruction set. The moment you switch to microcontroller family, they will be having a totally different phenomena, totally different operation. So it's always like you're dealing with a new processor. It's always like you're dealing with a new book. Alright, so every time when you switch from a previous processor to a new processor, we need to study the instructions what have been given from the manufacturer of this particular IC. Okay, so let's move further for 8086. It contains somewhere around 20,000 instructions. 20,000 instructions. So I may not be able to cover all of them in the classes, but I'll try to cover as maximum as possible in the classes because it's not easy to understand all of the instructions. So what the designers did, they created categories to understand those instructions in a better way. So these are the classification or the categories we are having of instruction set. First is called arithmetic instruction and logical instruction. Second, we have data transfer. Third, we have branch and loop. Next is machine control, then flag manipulation, then shift and rotate, then string instructions. All right, so we will study category by category, this classification by classification, and inside this I'll try to cover as many instructions as possible so that you could be able to have a brief overview about mostly instructions that we'll be using. Okay, the instructions that are mostly utilized in the programming and other stuff, I'll discuss those instructions which are mostly used. We'll discuss them in detail. Fine, so let's find the first one, what arithmetic and logical instructions category deals with. All right, am I still audible, loud and clear? Am I still loud and clear? Anyone?
Yes, sir.
Better. So let's see what is inside arithmetic. So arithmetic and logical instructions, just imagine why they are considered as arithmetic and logical, because they are dealing with ALU. Okay, so ALU deals with all the arithmetic as well as the logical operations. So whenever we talk about arithmetic and logical operations, they revolves around the operations of ALU. So what ALU can do? ALU can do all the mathematical operations, comparison operations, and the logical set of instructions. So just remember, they are related with the ALU operations. So like you can see on the screen, what this addition DES, SRC is going to tell us. Fine. So add ADD stands for addition, DES stands for destination, comma SRC stands for source. Now look into the example directly. Addition means it adds byte to byte or word to word, and after addition, definitely like we have seen earlier in the flag, after addition, if there is a flag which will be affected, like carry flag or some other flag, overflow flag, that flag will be definitely affected. You can see the example, add AL comma 74H. This means this is an immediate operand. 74 will be added immediately to the contents of AL. Next, add DX comma AX. Fine. So DX will be added with the contents of AX. Next, add AX comma bracket of BX. So I've already given you the meaning of the bracket. The bracket means whatever is inside the bracket, that will become the memory location. In this case, BX will provide the memory location of the source. Fine. So whatever is the contents of BX, that will become the memory location or offset. From that memory location, the content inside that memory location will be added to the contents of AX. So this is how the addition takes place. Is that clear? Is that clear? Tell me, is that clear?
Yes, sir.
Because this is the first instruction. Rest of the instructions will go parallelly like 50%. So if I replace add with ADC, ADC stands for addition with carry. Addition with carry. With carry means in this case carry flag will be acting like the ninth bit of the data. Ninth bit of the or 17th bit of the data. So it will be attached next to the AH or AX bit. So that means we can have the addition with carry. Carry will become part of the data. All right. Next is same parallelly. Everything will go same. Just in case of addition, there will be subtraction. So subtraction, the instruction is SUB. SUB. Fine. So in this case, subtraction will take place, and the only difference is in addition, the flag which will be affected, that will be a carry flag mostly. But in subtraction, the flag is also carry. The flag is also carry flag, but it is now known as the borrow flag. In the case of subtraction, carry flag will be known as the borrow flag or the borrow bit. Fine. So in this case, like we have done previously, add with carry, subtraction will take place with borrow. So that subtraction which takes place with borrow, that instruction is SBB. SBB, subtraction with borrow. Fine. So in this case, they will borrow that carry bit for the subtraction purpose. Is that clear? Is that clear? All right. Next is the multiplication, MUL. MUL is the opcode for the multiplication, but always take care of this thing while studying multiplication or division. Always look for the type of data they can handle. Fine. Like MUL is type of unsigned multiplication. Unsigned multiplication is for MUL. Fine. It will multiply the number. Like if you have 2 bytes or words, it will just simplify. It will just uh, multiply them. So what happens here is in this process, once we know the architecture type is von Neumann, and von Neumann again, we have seen already in the previous classes. Von Neumann says the accumulator acts like a bridge between ALU and the input outputs. Fine. Then from that we created a rule of programming that if you are having more than one numbers, like 2 numbers, out of these two, one number has to be stored in accumulator first for any ALU operation. So in these ALU operations, we are assuming that one number is already in accumulator. Same is the case with multiplication. In multiplication, the multiplication instruction is assuming that one number is already in accumulator. If it is 8 bit, AL or AH. If it is 16 bit, it has to be in AX. It has to be in AX. Fine. So what happens in the final instruction is this. The source will be the second number, the source that is written along with the MULSRC, that will be the second number you want to multiply with the contents of accumulator. So here the thing to remember is the accumulator will be holding one number out of any more than one numbers, which will be uh,
एक्सक्यूज
lined
मी
up
सर.
for yeah.
सर कोई है ना मीटिंग ज्वाइन नहीं करने दे रहा है, बार बार मेरे को रिमूव कर रहा है सर कोई.
Wait then. Okay, I hope now nothing will happen like this. Okay, get back to class. So we were talking about the multiplication. Multiplication assumes that out of two numbers, one number is already stored in register A, which is your accumulator, AL in case of 8 bit, AX in case of 16 bit. SRC will act like your second number, and it can be a register or it can be a memory location. Fine. So this is for unsigned multiplication. But when we have signed multiplication, the instruction is IMUL. IMUL. This is for signed multiplication. Right. So once you have signed number, you can have IMUL. If you have unsigned, you can have MUL. Likewise, we have DIV. DIV, you know, is for division. SRC stands for source again, and DIV again is for unsigned division. Unsigned. The instruction is actually same. IDIV. It is for signed division. Fine. So let's study about DIV first. DIV is unsigned division instruction. It again divides a word by byte or double word by word. Fine. The operand will be stored in AX. Divisor is SRC, what you will provide, and the result will be stored in that format. The format is, if the number is of 8 bit, fine, H will hold the remainder, AL will hold the quotient. Okay. If the number is of 16 bit, DX will hold the remainder and AX will hold the quotient in case the size of the number is bigger. Okay. So IDIV again is for signed division. Next is CBW. CBW stands for convert byte to word. It will convert the byte in the accumulator only. Fine. So if a byte is stored in AL, it can convert that it will be stored in AX by extension. Okay. Next is convert word to double word. It's like it can convert a 16-bit value to 36 value by extension. Next we have is the very important instruction called INC SRC. SRC again stands for SOAP. It can be a register or it can be a memory location pointing. What INC stands for? INC increments the value of source by 1 plus 1. So you can see in the example INC AX means the content of AX. What is inside AX, that will become plus 1. Next is INC bracket SI. So whatever the value we have in SI, once it is enclosed inside the bracket, that value will become a memory location, and that memory location must be holding an operand. So that operand will be plus 1. That operand will become plus 1 once you use it with INC SI. So increment is for plus 1. Likewise, DEC stands for decrement. Same बिल्कुल, just INC में plus 1 होगा and DEC में minus 1 होगा. It decrements the byte or word by 1. Next we have CMP space DES comma SRC. CMP stands for comparison. Right? So it compares two specific bytes or words. Now the condition is SRC and DES. They can be a constant, register, or memory location. Fine. The only condition we have here is in the CMP instruction, both operands cannot be a memory location at the same time. They can't be a memory location at the same time. Okay, so what happens here is comparison of two values will give you some condition, because we need to understand something by CMP. Once we compare something, that whether these values are greater than or less than or equal to, these three conditions we need to check, then only we'll be able to take the decision. Fine. So after comparison, your flags will be checked. Comparison is not a single instruction. Your flags will be checked after the comparison. Fine. Which flags? Carry flag, zero flag, and sign flag to indicate the result that this thing happened. Something is greater than this on the basis of this. So by observing the flags, you can take your decision that which condition is currently set. Okay. Next we have the negative NEG SRC. What NEG performs, it creates 2's complement of a given number. 2's complement of a given number. That means it changes the sign of the number. So if you take 2's complement of -4, definitely it will give you binary representation of +4. But actually it is -4. Next is DAA, decimal adjust after addition. Since we are already working in hexadecimal, but in some cases, in few cases, you want your answer to be in the decimal in some cases. So if you want to convert your answer into the decimal one after addition of something, it is for that. If you want to adjust the result to the decimal one. Same is for the subtraction, DAS, decimal adjust after subtraction. There are a few more instructions associated with the sky. They are just not relevant right now. Let's come to the logical instructions. In logical instructions, we know logical comes with a set. So what set we have here? Not, and, or, and XOR. This is the set we are having in the 8086. Not is actually the NOT gate. Fine. And what is the purpose of NOT gate? Is the complement. So whatever you have in the source, if you are applying NOT instruction to the source, what will happen? It will complement all the bits of that particular source value. Like you can see in the example, not AX. So once NOT is associated with AX, after execution of this, the value of AX will be complemented. Okay, so this is your NOT gate. Next we have AND. So if you remember the truth table of AND gate, even reply me when the output of AND gate is 1. Under which condition of inputs? The output of AND gate is 1. Tell me.
When all the inputs are set.
Yes, if all the inputs are set, then only we'll be having a set output. So this is the condition we need to check. Fine. So once we are going to do the ANDing operation of two numbers, it goes bit by bit. It goes bit by bit. So if first bit of the first number is 0 and the second bit, first bit of the second number is 1, 0 and 1 will be ANDed and it will give you the first bit of result. So once it is ANDed and there is a 0, the result will be 0. Next bit, then next bit. So that particular operation goes bit by bit. Bit by bit. Okay, so ANDing means you know what is going to perform is ANDing operation of source and the destination. The source can be an immediate number, the register or memory location, but destination can be a register or a memory location. Fine. Again, the condition both operands cannot be memory locations at the same time. Carry flag and overflow flag becomes 0 after the operation. Fine, and few flags other they will be always updated after AND. So likewise, AND we have OR. Everything remains same in always. OR destination comma source. There what we need to take care is the truth table of OR. That's it. Otherwise, the operation is same. ORing operation of destination and source. Same XOR operation. If you know the truth table, there is nothing complicated in this. It's very easy to understand. XOR operation of destination comma source. Next is bit manipulation instruction, which is called test. So test is not relevant right now. We can study it later. So let's move to the data transfer instructions next. This instruction I've already used a number of times, MOV. So, and we have discussed that in many places in the data addressing modes also. So move stands for data transfer. Fine. And the syntax is destination comma source. We have seen that. We can directly come to the example. Move cx comma 037a. 037a is the visible operand we are having. It is getting loaded inside the register C. Move AL comma BL. The contents of BL getting loaded inside the AL. Fine. So move is your data transfer. You know the syntax, source to destination. Next we have the push and pop. Both are related with the stack operations. Push means loading into the stack and pop means retrieving back from the stack. So we will discuss this thing in the detail once I'll be having a tutorial class or some other class, because push and pop, they are very complicated to understand sometimes. So push and pop will be taken later. Exchange, yes, definitely, very good example. Exchange destination comma source. So this instruction actually, it exchanges the contents of source with destination. And only thing to remember is that it cannot exchange two memory locations directly. Memory locations में exchange को नहीं use करना है. Exchange will only be used with the register. So you can see the example XCHG DX comma AX. DX comma AX. That means exchange the contents of AX with DX and DX with AX. A के content D में चले जाएंगे, D के content चले जाएंगे A के अंदर. This is what exchange is. Now after this is a data transfer instruction. So what happens in the case of these two instructions we are watching right now, IN and OUT, out. Fine. So what we know about computing system, that computing system interacts with outer signals via ports. That's why there are so many ports in your laptops or desktops or computers. Fine. You have multiple USB ports, HDMI ports, VGA, mini display ports, LAN ports, and sometimes printers were having LPT1 ports in the past. So there are altogether there are many ports we are having, and some of them are input ports, some of them are output ports. Input means from that particular place something will travel inside the system. Output port means something will travel from outside, so from inside of the system to outside in a device or in some memory location. Fine. So let's talk about input first. So once you connect your pen drive to a USB port, so pen drive is what? It acts like an input device. You copy the content. It can act like both, but right now let's say I want to copy the data from the pen drive inside my system. Right. So that means it will be acting like input, but that phenomena has to follow through a port. Has to follow through a port. Right. And every port has a physical, digital, verified hardware address, which is called the port address. Right. So जितने भी ports आप desktop और laptop में देखते हो ना, every port has a particularly designed number. Fine. So once we connect anything, or once we want to create a system, we are creating the motherboard right now. So once we are using processor, so we will design the port addresses also. The port addresses हम खुद से भी डिजाइन कर सकते हैं या फिर हमें दिए भी हो सकते हैं. So let's say 0028 is the port address of somewhere. So what is going to happen in source is the port address 0028 from where the value is coming. So after coming, or after an incoming, I say better, where this value will go. Now give me an answer. The moment you enter in your class, not the virtual class, your physical class. After entering into the class, what is the next thing you see? Tell me, after entering into the classroom, what is the first thing that you see or seek?
Empty space.
Yeah, there is a vacant spot. I need a vacant spot so that I can sit and attend the class, isn't it? So same thing happens here. Once the data is traveling via port and it is going to settle inside somewhere in your computing system, so that place will be your destination, and destination will always be accumulator, because Von Neumann told us whatever happens, the input or output, accumulator will always act like a bridge to the incoming data or leaving data. Fine. So again, this is again the third application of accumulator. It even acts like a bridge or storage for data which will be going outside, or the storage for the data which will be coming from outside. Okay, so 0028 is the port address for input, and from where the data is coming, and it will be stored into the accumulator immediately. Fine. So in is the instruction for input port. Likewise, out, if you want to transfer something out, अब आपको data बाहर भेजना है तो कहाँ से भेजना है? तो source क्या होगा हमारा? Source will be accumulator. Look into the example. The source will be accumulator, and उसको out कहाँ से करना है? This is the port address. It is to be written in that way. All right. So there is a particular way of writing everything. So we are having this class time. So we'll start from this LEA, LDS, LES in the next class, and then we'll start with the branching and other. So